Welcome to the Deep Dive. Today, we're tackling a core challenge in software, really. How do teams actually know they're heading in the right direction?
Yeah, it's a big one.
We're digging into the crucial methods they use to ensure they're building a product that resonates, crafting it with quality, and navigating the development process effectively.
Right.
We've assembled a really rich set of resources. Think of this as your shortcut, maybe, to understanding the reviews, metrics, practices that, really make the difference.
Absolutely. Between software that hits the mark and software that just doesn't.
Exactly.
And if you've ever wondered how some software teams seem to consistently deliver valuable products while others struggle, well, this is definitely for you. We know you're looking to get informed efficiently, thoroughly.
Yeah.
So our mission today really is to distill the most valuable insights from our material and understand these key reviews, metrics, practices that fuel continuous improvement both in the software itself and how it's made.
That's right. And to keep things focused, we're looking at three fundamental goals in software development. First, making sure we're building the right product, something that truly meets user and stakeholder needs. Second, ensuring it's done right, high-quality code, clear requirements, a solid system.
Quality, yeah.
And third, that the whole thing is managed right, keeping the project productive, the team working at a pace they can sustain.
Right, sustainable pace is key. And as we'll see, different techniques come into play for each of these critical areas.
Okay, so let's get started with that first challenge then. Building the right product.
Okay. So when we talk about building the right product, a foundational idea, especially in agile development, is continuous monitoring.
Monitoring, like watching people code.
No, not quite like that. It's not about keeping tabs on every keystroke. It's more about fostering transparency and getting feedback early and often.
Okay.
It just helps everyone stay on the same page about where the project stands. And within this, it's useful to distinguish between verification and validation.
Verification and validation. Okay, what's the difference there?
So verification asks, are we building the product correctly? According to the specs, think unit tests, quality checks, that kind of thing.
Right. Do we follow the blueprint?
Exactly. Validation, though, asks the more crucial question, are we building the right product? Does the software actually meet the needs and expectations of the stakeholders once it's out there?
Okay. So not just if it works, but if it's the right thing people actually want.
Precisely. And this is where that agile principle of frequent delivery is so powerful. Getting working software in front of people early lets you course correct if you're, heading down the wrong path.
That makes a lot of sense. And one of the main ways to get that validation feedback in Agile is the sprint review meeting, right? That happens at the end of each sprint.
Correct. A sprint being that short, focused work period.
Yeah. So at the end of that, the review meeting is where they show what they've done. What's the main goal of that meeting?
The main goal is to present the product increment that working software delivered during the sprint to the stakeholders and, critically, get their feedback.
So it directly asks, are we building something valuable here?
Exactly. It's the chance to see if what was delivered actually lines up with their vision. A really good sprint review isn't just a demo, it's a genuine conversation.
Okay, so who needs to be there and what are their roles in making that feedback loop actually work?
Well, you typically have the Scrum Master who facilitates, keeps things on track.
Right.
The product owner is absolutely key. They're the voice of the customer, deciding if features meet the vision. They're the ones saying, yes, this is what we asked for.
Gotcha.
Then you have the development team, obviously. They built it, they demo it. And finally, the stakeholders themselves, users, customers, internal teams, anyone with a real interest. Their role, provide that crucial feedback.
And what does a typical sprint review actually look like? What happens?
Usually, the Scrum Master kicks things off, maybe reminds everyone of the sprint goal for context.
Yep.
Then the main event, the product demo by the dev team. And it should be the real software shown realistically, not some mock-up.
Right. No smoke and mirrors.
Exactly. And only features that meet the team's agreed definition of done, coded, tested, documented, whatever the criteria are, should be shown. Incomplete stuff isn't ready for feedback.
Makes sense.
Yeah.
Show it's real and meets the quality bar. What happens after the demo?
After the demo, the product owner steps up, reviews the features. If they align with expectations, they'll typically approve them.
And that means they come off the backlog?
Yep, eventually. Maybe right there, maybe shortly after if they need a closer look. But approved means it's considered done for now. Then the stakeholders share their feedback.
And this could be anything.
Pretty much. praise, suggestions for tweaks, identifying new problems, even questioning old assumptions. They might suggest new features too, but ultimately the product owner decides what goes back into the backlog.
Okay, so the key is getting that active engagement from stakeholders.
Definitely. The best feedback often comes when they feel encouraged to really think critically about what they're seeing.
So sprint reviews give us that direct line to stakeholder feedback. But what about the actual people using the product day to day? How do we make sure it's right for them?
That's where user studies come in. Sprint reviews are great for the stakeholder view, but user studies focus specifically on the end users and, crucially, the usability of the product for them.
Usability, how is that defined?
Well, the ISO definition basically boils down to three things. Effectiveness, can users actually achieve their goals? Efficiency, how much effort does it take? And satisfaction, how pleasant is the experience?
Effectiveness, efficiency, satisfaction.
Got it.
So how do these user studies actually work?
The core idea is simple. Watch representative users interact with the product, usually in a controlled setting, though remote studies are common now too.
So you give them tasks.
Sometimes, yes, specific tasks to see if they can complete them, or you might let them explore freely. Researchers observe their actions, listen to them often using a think aloud protocol where users narrate their thoughts.
Think aloud, okay.
Yeah, it reveals their thought process, confusion points. Critically, the participants have to be representative of your target audience background, tech skills, etc.
And unbiased, right? Not the developer's friends.
Ideally, yes, unbiased selection is key, and you want a consistent environment for reliable data.
Makes sense. Are there different kinds of user studies?
Oh, absolutely. Loads. You have those task-based studies we mentioned, exploratory studies with Think Aloud, shadowing users in their actual environment that can be incredibly insightful.
Shadowing, like following them around.
Sort of, yeah. Observing them use the software in their natural habitat. Then there are cognitive walkthroughs where experts simulate being a user, A/B testing, comparing two versions, longitudinal studies, tracking users over time.
Wow, quite a toolkit. And how do you measure success from these studies? What kind of data are you after?
You look at both objective and subjective data. Objective is the quantifiable stuff, task completion time, error rates, number of clicks, things like that.
Our numbers.
Right. Subjective measures capture perceptions, satisfaction ratings, comments on ease of use, aesthetic appeal. You really need both.
Why both?
Because they can tell different stories. Someone might finish a task super fast, high efficiency, but find the whole process incredibly frustrating, low satisfaction. You need the full picture.
Gotcha. Objective data and subjective feelings. So we've talked about feedback from stakeholders and end users. Can you give some concrete examples of how big companies actually do this right product stuff?
Sure. Apple, for instance, is famous for its intense prototyping, that 10 to 3 to 1 idea.
10 to 3 to 1.
Yeah, they might start with, say, 10 concepts, prototype 3 more deeply, then refine one to an incredibly detailed, almost pixel-perfect level before coding starts. Plus, they have notoriously rigorous design reviews with execs and peers.
Very high bar. What about Google?
Google popularized the design sprint. It's this super compressed 5-day process usually, taking an idea from problem understanding right through to user validation with a prototype. Understand, diverge, decide, prototype, validate. Very fast, very iterative. Lots of companies use it now.
5 days. Wow. Others.
Intuit, the QuickBooks people, they pioneered the follow me home approach.
Follow me home. Sounds a bit creepy.
Maybe a little, but it's effective. Developers and designers literally go to customers' homes or offices and watch them install and use the software. You get incredible first-hand insights that way.
I bet. Real-world context.
Exactly. And IBM uses design thinking, which is a broader framework combining prototyping, user observation, agile. They talk about sponsor users who really know the audience, defining the problem with concise hill statements and frequent playbacks for feedback.
So lots of methods, but the common theme seems to be really deeply understanding and checking in with users all the time.
That's the core of it, yeah. Continuous validation.
Okay, great. Let's pivot now to our second goal, ensuring the product is done right. This is about the quality inside the software code, architecture, reliability. Where do we start there?
Ensuring it's done right often comes down to various review techniques, especially peer reviews.
Peer reviews. So developers looking at each other's work.
Exactly. It's about catching potential defects early when they're cheaper and easier to fix, and making sure everyone's adhering to quality standards.
Makes sense. What kinds of peer reviews are common?
Well, you've got software walkthroughs. These are usually the most informal. Think of a developer doing a quick show and tell of their code or design to a few colleagues.
Just like, hey, take a look at this.
Pretty much. The focus is quick feedback on obvious stuff, reliability, security holes, readability, coding standards, catching major issues quickly, low overhead.
Okay, informal and fast. What's a step up from that?
That would probably be the software technical review. It's more formal, more discussion-based, and zeroes in on the technical aspects, design choices, architecture, algorithms.
So digging deeper into the how.
Right. The goal is a more robust design. Technically sound requirements, identifying technical improvements. There are usually defined roles, like a decision maker, a review leader, a recorder to document issues. And crucially, everyone's expected to prepare beforehand, review the materials.
More structure requires prep work.
Got it.
And then the most rigorous type is the software inspection.
That's right. Software inspections, sometimes called formal technical reviews, are very structured. Rigid process, specific roles, author, moderator, reader, inspectors, recorder.
Wow, quite the cast.
Yeah, the moderator runs the show, the reader walks through the document systematically, inspectors actively hunt for defects, recorder logs everything. It's a multi-stage process. Planning, overview, preparation, the inspection meeting itself, rework by the author, and follow-up to check the fixes.
That sounds incredibly thorough, almost forensic.
It can be, but that rigor makes them really good at finding subtle, critical defects that other methods might miss.
Okay, are these reviews just for code? What about the requirements themselves? They need to be right too.
Excellent point. There are specific review processes just for requirements. Requirements technical reviews aim to ensure high-quality requirements before development starts.
So catching problems upstream.
Exactly. Ideally, the reviewers weren't involved in writing them to get fresh eyes. You have the author, a moderator, maybe the scrum master, and a recorder.
And the process.
Typically 2 stages. First, a review stage where reviewers check the requirements individually against criteria. Are they correct, complete, clear, consistent, verifiable, feasible, traceable? You get the idea. They also classify defect severity.
Clear, consistent, verifiable. That's a good checklist.
Yeah. Then there's a time box discussion meeting to clarify issues, maybe reclassify severity. After that, the author fixes things.
And is there a formal inspection for requirements too?
Yes. Requirements inspection. Similar formality to software inspection, focusing on making sure user stories or requirements docs are clear, consistent, and complete. Inspectors look for ambiguity, inconsistency, missing pieces. The author must fix the issues found and present the updates.
Okay, a whole suite of review techniques. Now, our sources also talked about potential problems with how teams monitor their work, like with metrics. What issues come up?
Yeah, several pitfalls. One big one is just skipping metrics entirely. Teams might say they don't have time, or there aren't good industry standards, or managers don't see the value.
But that means flying blind.
Pretty much. You can't spot problems or see if you're improving. Another trap is using ineffective metrics or misusing them, measuring stuff just because it's easy, like lines of code.
The classic LOC metric.
Right. Easy to count, but what does it really tell you? Not much about quality or functionality. Can even incentivize bad behavior, like writing bloated code.
Yeah, measuring the wrong thing.
Or trying to measure absolutely everything. You just drown in data, lose focus on what actually matters for success.
That reminds me of that quote, not everything that can be counted counts.
And not everything that counts can be counted.
Exactly. So how do we avoid this? How do we pick good metrics?
Okay, that's where the goal question metric method, GQM, comes in. It was pioneered by Victor Basili.
GQM, goal question metric.
Right. It's a structured way to choose metrics that actually mean something. You start with your goals. What are you trying to improve? Code quality? Testing efficiency? User satisfaction?
Start with the why?
Precisely. Once you have clear goals, you define specific questions you need to answer to know if you're achieving those goals. Questions need to be focused, measurable.
Okay, goals, then questions.
Then finally, you pick the metrics, the specific things you'll measure, quantitatively or qualitatively, to answer those questions.
So it's very intentional. Goal leads to, question leads to metric.
Exactly. It's a lot like requirements gathering. Really understand the objective first. And GQM metrics can be objective, like defect counts or response times, or subjective, like customer satisfaction scores.
Can you give a quick example?
Sure. Goal, improve customer satisfaction. Question, how reliable is our product? Another question, how fast is it? Metric for reliability, maybe defect density. Metric for speed, average response time. Another question, how satisfied are users overall? Metric, customer ratings from surveys.
Got it. And I think the source mentioned FURPS plus is helpful here.
Yeah, FURPS plus functionality, usability, reliability, performance, supportability, plus other constraints can be a good framework to brainstorm those questions within GQM.
Okay, so we have a method for picking metrics. What makes a metric good, though? What are the desirable properties?
Good question. A good metric should be simple and computable, easy to understand and calculate.
Makes sense.
It should be intuitively persuasive. Its relevance should be pretty clear. Objectivity is important based on measurable data, ideally. Consistent units so you can compare over time. Language independent, if possible. And critically, it should provide an effective way to drive improvement. The data needs to lead to action.
Actionable insights.
Right. And it helps to distinguish. A measure is raw data. A metric processes that data for meaning. And an indicator is a metric that flags something needing attention, like heart rate is a measure, average resting heart rate is a metric, and a sudden spike might be an indicator.
Okay, that's a helpful distinction. So simplicity, relevance, objectivity, driving improvement. What are some popular metrics teams actually use for things like non-functional requirements?
Well, for maintainability, you see complexity metrics trying to measure how tangled the code is.
High complexity means hard to change.
Generally, yeah. For performance, response time is king. How fast does it react? Reliability is often tracked by system uptime, percentage of time it's available.
Right.
Product success often uses customer satisfaction scores, ratings, net promoter score, stuff like that. Correctness, interestingly, is often handled through defect analysis.
And unpopular metrics. Lines of code again?
Lines of code, yeah. Documentation size, maybe. Things that don't reliably correlate with value.
Okay. You mentioned defect analysis for correctness. Can you unpack that a bit more? How does analyzing defects help ensure quality?
Defect analysis is huge. It's about systematically looking at the errors or failures found in the software. You track them both before release, during testing, and after release reported by users.
Pre- and post-release.
Yeah. And you compare the rate you're finding defects versus the rate you're fixing them. It gives you a sense of whether you're actually getting on top of quality issues.
So if you're finding them faster than you're fixing them, that's a bad sign.
It can be. Sometimes there's this idea of a software barrier where found defects equals fixed defects. It might mean your current process isn't improving quality and maybe you're not ready to release.
Interesting. What else can you learn from defects?
You can analyze them by subsystem or module, identify error-prone areas that need more testing attention, or maybe even a redesign.
But you need to account for size, right? A bigger module might naturally have more bugs.
Exactly. You need to normalize, often by looking at defect density defects per 1,000 lines of code, usually.
Defect density, KLOC.
Right. That gives you an overall quality snapshot and helps assess release readiness. You compare it to past releases, industry benchmarks maybe. You can even use it to predict remaining defects, like that rule of thumb, find 90% before release for a stabler launch.
That's fascinating. Is there a standout example of defect analysis making a huge difference?
Oh, absolutely. The classic one is the IBM software for the NASA Space Shuttle's primary flight control.
The super reliable one.
Incredibly reliable, like one error per 420,000 lines of code, reportedly. That wasn't luck. Their defect analysis was intense. They didn't just fix bugs, they categorized every single one, did deep root cause analysis.
Figured out why it happened.
Exactly. And then they proactively looked for similar potential issues elsewhere in the code and adapted their development process to prevent those kinds of defects in the future. That deep analysis was fundamental to achieving that quality.
Wow. That really drives home the point about learning from errors, not just fixing them. Okay, we've covered building the right product, done right. Let's hit our third area. Managing the project right, keeping things on track, effective teamwork, sustainable pace. Where does that start?
In Agile, a key practice for managing the day-to-day is the daily scrum, or daily stand-up in XP.
The stand-up meeting. Usually short, right?
Yeah, typically 15 minutes, time-boxed. It's held every day for the development team to synchronize their work and plan for the next 24 hours.
Who's usually there?
Yeah.
And what actually happens?
Core participants are the developers doing the work. The Scrum Master is usually there to facilitate. Product owner might listen in, but it's really for the devs, often held standing near the task board.
Standing keeps it short.
That's the theory. Each person typically answers 3 questions. What did I accomplish yesterday towards the sprint goal? What will I do today towards the goal? And are there any impediments blocking me?
Yesterday, today, blockers. Simple. What's the Scrum Master's role?
Facilitation. Keep it focused, keep it within 15 minutes. If a discussion gets too deep, they'll suggest taking it offline in the parking lot.
Right.
And they crucially note down any impediments raised and make sure someone follows up on getting them resolved after the meeting. It's really important to remember it's for the team to coordinate with each other. It's not a status report for the boss.
Not for management, for the team. Got it. What are some common problems with daily scrums? They sound simple, but I bet things go wrong.
Oh, definitely. Getting started, figuring out who speaks, when that can be awkward.
Yeah, the awkward silence.
Right. Some teams have the last person to arrive speak first encourages punctuality. Or pass a token around. Or just simple round robin.
Okay, what about going overtime?
Very common. Remind people just the 3 questions. Use the parking lot aggressively. Stand up. Some teams use a heavy-ish object as the talking token to encourage brevity.
Huh, a heavy token. Nice.
Yeah.
What if no one mentions impediments?
The Scrum Master can prompt. Share impediments they know about. Ask open questions like, what can I or the team do to make your day easier?
Proactive impediment seeking.
Yeah. Flexible hours can make scheduling tricky. Maybe an after-lunch stand-up works better for some teams. And preventing it from becoming a status report, sometimes asking people not to look at the manager when they speak, helps focus it back on the team.
Good practical tips.
Yeah.
Okay, another key management metric in Agile is velocity. Remind us what that is.
Sure. Velocity, as we covered in the Agile Planning Deep Dive, is basically how much work, measured in story points usually, a team completes and gets to done in a typical sprint.
Right, the team's throughput per sprint.
Exactly. Teams estimate future velocity based on past performance. Or initially, they might use a work breakdown structure to estimate task effort and get a starting point. It might fluctuate early on, but it should stabilize.
And velocity feeds into those burn down charts.
Precisely. Yeah. Both release burndowns for the whole project and iteration burndowns for the current sprint rely on understanding velocity.
Okay, so let's talk release burndown charts. How do they help manage the project overall?
They're a visual tool, mainly in Scrum, to see the big picture progress. It shows the total work remaining, usually in story points at the start of each sprint.
So the line should go down over time?
Ideally, yes. As the team completes work each sprint, using their velocity, the remaining work decreases. You plot this sprint by sprint. By drawing a trend line based on their actual velocity, you can forecast a likely completion date for the whole release.
And if the line isn't going down fast enough?
Then the chart visually flags that you might be behind schedule. The actual burndown line will be flatter than the projection, prompting a conversation about scope, resources, or timeline.
Can you describe what one looks like?
Imagine a graph. Horizontal axis is sprints, sprint 1, sprint 2, etc. Vertical axis is total story points remaining. Start of sprint 1, you have a tall bar showing all the work. End of sprint 1, after completing some points, the bar for sprint 2 start is shorter. Connect the tops, that's your burn down. Add a prediction line based on average velocity.
Simple visual. Okay, and projects change, right? Requirements get added or removed. How do burn downs handle that?
Good question. Happens all the time in Agile. Release burndowns need to show scope changes. 2 common ways.
Okay.
One way, show completed work going down, but if scope is added, you might add height back to the remaining work bar, maybe visually distinct, shows progress and scope change. You have to adjust velocity calculations then.
So the total target moves up.
Right. Another way is an adjustable floor. Added scope extends the bars below the original baseline. The prediction line gets recalculated based on the new total scope.
Below the line, interesting.
Yeah, both work. It's often team preference, and you can show these as line charts too, not just bars. The key is visualizing both progress and changes to the overall work.
So release burn downs track the whole release. What about within a single sprint, day to day?
For that micro-level view, you use iteration burn-down charts, or sprint burn-downs. Focus is just on work remaining within that one sprint, tracked daily, usually in task hours.
Daily tracking in hours.
Yep.
Okay. Similar look.
Similar idea, yeah. Often includes a prediction line or bar graph. Maybe keep it consistent with your release burn-down style. Horizontal axis is days in the sprint. Vertical is total remaining task hours. Skips weekends, usually. Updated daily, often during the daily scrum, using info from the task board.
Ah, the task board. How does that connect?
The task board is the physical or digital visualization of the sprint work. User stories might be in a to-do column. They're broken into smaller tasks, sticky notes maybe, with estimated hours.
Right, the classic sticky note board.
Exactly. As devs work, tasks move across columns, in progress to verifying done. When a task hits done, its estimated hours are burned on the iteration burn down chart. The total remaining hours goes down.
So moving stickies updates the chart.
Directly. Task board movement drives the burn down line.
Gotcha. And do you usually need the adjustable floor for scope changes on sprint burndowns?
Generally less critical. The focus is sprint execution. Major scope changes mid-sprint are discouraged anyway, but if tasks are added or removed, you just adjust the total remaining hours. Simpler charts usually suffice.
Okay. Our sources mentioned looking for patterns on these sprint burndowns too, like early warnings.
Yes, they're great for spotting trouble mid-sprint. Two key patterns, burning up and burning across.
Burning up sounds bad.
It is. The remaining work line goes up, means more task hours are being added than completed. Often points to poor sprint planning, scope creep within tasks. Solution, replan, remove lower priority tasks.
And burning across.
That's when the line stays flat. No progress being made on reducing remaining hours. Could be tasks are being added as fast as they're finished, tasks aren't getting fully done, or maybe people aren't working effectively.
So a stall.
Yeah. The fix is often emphasizing finishing work before starting new stuff, team members helping each other clear blockers. It really helps with day-to-day management.
Very useful indicators. Okay, we've hit right product, done right, managed right. The final piece is learning and improving project retrospectives. What are they?
Project retrospectives, sometimes called postmortems, are sessions where the team reflects on a whole completed project.
Not just a sprint, the whole thing.
Right. The goal is what went well, what didn't, and crucially, what specific actions can we take to improve next time? Lessons learned. Broader scope than sprint retrospectives, often looking at team dynamics too.
Capturing those big picture lessons. Why are they so important, and what makes them hard to do well?
Vital for continuous improvement. Honest reflection helps teams keep doing what works and stop repeating mistakes. And because the team usually picks the topics, they're more motivated to actually implement the improvements.
Makes sense. What are the challenges?
Lots of reasons they get skipped. No time, want to move on, discomfort with reflection or admitting mistakes, burnout. Sometimes they're just done to tick a box.
Yeah, just going through the motions.
But the biggest hurdle, often, is the lack of a psychologically safe environment. People need to feel safe to be honest, even vulnerable, without fear of blame or negative consequences. If that safety isn't there, you only get surface-level feedback.
Psychological safety. That sounds critical for honesty. How do you build that?
It starts with leadership, setting the tone. This is open, blame-free, all perspectives valued, actively appreciate contributions even if you disagree. Frame your own points as feedback, invite discussion, build on others' ideas, give credit, model the behavior you want to see, constantly reiterate. It's about improving the process, not blaming people.
Leading by example, reinforcing the purpose.
Yeah.
What does a healthy versus unhealthy team culture look like in this context?
Healthy culture. Active participation, shared ownership of success and failure, constructive focus on improvement, driven by the team's desire to learn. Dysfunctional. Reluctance, defensiveness, blame games, secrecy, unhealthy competition, no follow-through on actions.
Big difference. I think the sources mentioned outside facilitators.
Yeah, sometimes bringing in someone neutral, skilled in facilitation can really help, especially if there's tension. They can create safety, ensure equal voice, guide tough conversations. They need to understand the goal of the retrospective, though.
Okay, so retrospectives happen at sprint level and project level. And the sources described a really in-depth approach for project retrospectives, right?
Yes, Norman Kurth's work outlines a comprehensive, often multi-day approach. He calls it a 3-course meal. Readying course, appetizer, past course, main course, future course, dessert.
A multi-day retrospective, that's a big commitment.
It is. But the idea is the potential payoff in uncovering deep issues and making significant future improvements is worth the investment.
Okay, tell me about these courses. What happens?
Well, even before the meeting, there's often preparation exercises, maybe a handout with reflection questions sent out beforehand, get people thinking.
Through work.
Then the readying course sets the stage. Introductions, agenda setting, defining success for this team on this project, maybe explicit safety building exercises, like a quick anonymous poll on how safe people feel.
Addressing safety head on.
Yeah. And sometimes fun stuff like an artifacts contest. People bring project-related objects, share stories, helps build connection and recall the whole journey.
Artifacts contest, I like that. Okay, What about the past course, the main meal?
That's where you really dig in. Often starts with create a timeline, collaboratively mapping out significant project events on a wall, creates a shared history.
Visual timeline.
Then maybe an emotion seismograph, people draw their emotional highs and lows along that timeline. Adds another layer.
Interesting. Connecting events to feelings.
Yeah. The core is usually the Mine for Gold exercise. You examine the timeline period by period using prompts like, what worked well? What did we learn? What to do differently? What still puzzles us? What needs more discussion? Capture it all on charts.
Mining for gold, looking for those nuggets of insight.
Exactly. And maybe sprinkled throughout an offer appreciations exercise where people explicitly thank each other for specific contributions, builds positive connections.
Acknowledging the good stuff, too. And finally, the future course. Dessert.
This is about looking forward and tackling tricky issues. The Making the Magic Happen exercise helps surface sensitive topics the facilitator guides carefully. Then, closing the retrospective ties up loose ends. Maybe anonymous hope wish cards are shared. And on a positive, forward-looking note.
Wow, that is a deep dive. From setting the stage, analyzing the past, planning the future. Very thorough. Okay, as we wrap up this deep dive, let's quickly recap the main areas.
Sure. We started with building the right product using feedback loops like sprint reviews with stakeholders and user studies focusing on end user.
Right, getting that validation.
Then ensuring it's done right through peer reviews like walkthroughs and inspections and using effective metrics, maybe chosen via GQM. Defect analysis plays a big role there too.
Quality checks and measurement.
Then we talked about managing the project right, daily scrums for team sync, using velocity and burn down charts, release and iteration for progress tracking and forecasting.
Keeping it on the rails.
And finally, the Learning Loop project retrospectives, both sprint level and the deeper project level kind, to drive continuous improvement.
And all these methods, pulled from our sources, really offer a structured way to keep getting better, both the product and the process. Understanding them gives you real insight into how software teams try to achieve quality and efficiency.
Exactly. So maybe a final thought for you, listening. Even if you're not in software, think about these principles. Regular feedback, quality control, structured reflection. Which of those could be most powerful in your own field, your own projects? Because that drive to improve and learn from experience, that's pretty universal.